Hello, today's coding problem is flag in Codility Lesson 10. In this question, it assumes that the user is going on a trip to the mountain. And here, there are given integer array. Each value means the height of the mountain, as shown here. You can see there are peak on mountain, and user can put flag on peak. Question is to find the maximum needed number of flag, but there are one condition to follow that distance between two flags should be longer or equal to the number of flag. This makes problem confused. Okay, let's think of solution. Here is the graph and it has several conditions to think, so let's split the approach. First, we need to know where is the peak. Peak should be the position where the previous value and next value inside array is smaller than itself. So let's make as inside the graph, it looks like this will be the peak, and inside the input array, it'll be 4, 4, and 6. So the position is 1, 3, and 5, and 10. Next, make one more array. Next, peak. And fill the value of position where the next peak is. If we think of example here, should be start with 1 because first peak position is 1, next is 1, and next peak is at 3. So fill 3 until it goes 3. Next is 5. So add 5 here until it goes 5. And next is 10. So fill out 10 until position 10. Okay, next. Next, as in precondition, if number of flag is k, position of flag 1 and flag 2 should be equal or bigger than k. So that means flag 2 should be equal or bigger than flag 1 plus k. So if size of input is n, we cannot bring flag more than n by 2k plus 1. And this means n divided k plus 1 should be equal or bigger than k. And change it to n by 2k will be equal or bigger than k minus 1. And time multiple k to both sides, then it will be n should be equal or bigger than k times k minus 1. So this means that this is the possible case for the solution. So we'll make loop with this. And inside the loop, we'll assume the cases when user bring flags 1 to k and check whether it is possible to put in peak with generated array here. Okay, with these, I'll make logic to calculate the result. Okay, here's the next peak value, which I've created previously. And let's put -1 at the last. Okay, let's assume each cases. Let's start with when the flag is 1. Going through the array, in first value it is 1. It means position 1 is peak. So put flag here. Now we use all flag because we brought only 1. So close this loop, and if flag is 2, first put flag in 1, and because we brought 2 flag, next position will be 1 plus 2 means 3. And value in position 3 is 3 again. So put flag here. So it's 1, 3. We used all flag. So go to next loop. When you brought K3, start with 1. And next position is 1 plus 3. So the value here is 5. So we need to put flag in 5. Next possible position will be 5 plus 3 is 8. And if we go to 8, it is 10. So put last flag on 10. We've done it all, so go to next. In 4, the result, the flag position becomes 1 plus 4 is 5. So flag position is same. And next will be 9, but flag position will be 10. So it is same as before. And for 5, in precondition, as we have discussed, 5 times 4 is 20, bigger than the size of input. So it is out of scope, which we have defined here, as we have commented that the scope is k times k minus 1. This value should be smaller than the size of the array. Let's make some note for coding. First, we need to find out the peak. Find peaks, which will return position list of peaks. So input is array, and it'll be pretty simple. Need to find the value in array, where previous value and next value is smaller than itself. So make loop for I in range of array. And if check whether itself array I bigger than max value of previous array I minus 1 and next one array I plus 1. And if it is bigger, append to the temporary array, and after the loop, just return the peak, which will include the position information of peak. And next is to make array, which has the position information of next peak. given parameter will be array and the peak array, which we've calculated previously. Make empty array. Next, this will have length of input array, but the last value will be -1, and loop through the input array. In reversed way as commented here, so we will start from the back. If position includes in peak, then put the next inside the next array, put value I, and else, then put the value which has been filled in after position, I plus 1, to let data in previous position knows where the peak is, and return next. And make last function get max, input is array, and the next peak, let's rename as NP, which includes next peak, which we have calculated just before. Let's make two variables, k and max flag. K will be the number of flags to bring. Max flag will be the maximum number of flags which can be carried on. And n, which is length of arrays. And let's make while loop. And as we have commented, it will run inside k times k minus 1 is smaller or equal than n. And inside, I'll make one more loop while position is smaller than n and flag in peak is smaller than k. So set up variables. Position here should be defined by values in peaks because we need to find the closest peak location. So pos is from np pos. And move next position by adding k, because this is the least value of distance with next peak. And we have used one flag, so add 1 to k. Repeat this process inside loop and keep compare max value of flag with current flag and update it if new flag is bigger. So max flag is max of max flag and flag data. Okay, after the loop, then return the max flag here. Okay, this is all for the description. So let's start coding with this. Okay, here I'll add some private function. Return integer array, and name is get next peak to return the next peak array. Input will be the input array and the size of input. Okay, first let's set up the set with integer to store the peak data inside the input array, and the next with integer array, which will be the output of this function, and the last value will be -1. So first let's find peak. For loop, start with 1 and finish with n-1. And if it is a peak, which means the position A is bigger than the previous one, A minus 1, the next one, A plus 1. Then to peak array, the peak set. And for integer b, let's start with backward. And if the peak contains, which means that value is peak, then put into the next array, or else put the value in after, so we could know that where is the next peak. Okay, return next. Okay, this is all for get next peak, and let's implement the main function here. N will be the size of input. The next peak is the value from get next peak. Input is A and N. And K is 0. Max flag to keep the maximum value of flags. Okay, let's start with while loop here. While K times K minus 1 is smaller or equal than N, and make another variable here, and impose position information and flags. And make another while loop here, where the position is smaller than N, and the flag should be smaller than K. And first define position as the position value inside next peaks. And after position, shift the K next value. And because we used flag, let's add one value let's plus 1 to the flags. And one more here. If the position is the last one minus 1, then break. And after the while loop, then give max flags, the bigger one, between max flags and flags. And add k. Okay, and finally return max flags. Looks it is okay, so let's run the code. Okay, sample runs well and submit it. Okay, it looks well. Looks no problem with the solution here. Okay, now let's try with Python. Change the setting with Python and okay, same as Java. Let's make some function. Name will be get next peak, and input is A and N. Peak given as set. Not this one. And let's make for loop. Range will be 1 to n minus 1. If A max, it means bigger than the previous. Next. Then append to the peak. And prepare next. This will be the array and size of n. And the last value, next, minus 1, should be minus 1. And make another for loop here. Range, it will go to the backward. Reversed. If B in peak, then next value should be itself B, and or else next B will be the value and the value afterwards. And finally return next. Okay, this is the function to get next peak array. And let's start to implement main part. Let's make k and max flag and get n with length of a. And copy get next peak with variable a n and give to the next peak variable. Start with while loop k times k minus 1 is smaller or equal than n, and give another post and flags. And inside, another while loop with post is smaller than n, and flags are smaller than k. First, define post as the position of next peak, and shift post to k. And because we flagged to the peak, so flag are +1. And don't forget to give break when post is -1. And outside of inner while loop, update max flags with bigger value between max flags and flags, and add 1 to k. And return the max flags as result. Same as Java, it has been done, and remove pass. Okay, let's run sample. Okay, sample works well. And before submitting, let's look on through the complexity of this solution. First, inside the next peak, which is get next peak. If you see here, yeah, there are 2 for loops, but it is not nested, so the time complexity here is O(n). And there are while loop, and this loop will be run until k squared is smaller or equal than n. So the time complexity of this while should be O, the square root of n. And there are inner while loop here, and this is also same as top. So the total time complexity of this while is the square value of square root, like this. Remove it, and so the total time complexity of this solution, O(n) plus O square root n's squared, so it equals to O(n). And for space complexity, if you see here, there are only next peak, which contains the next array, which linearly increased by n, so it is O(n). Okay, it's done, so let's submit the task. Okay, results are perfect. So this is all for today's video. Thanks for watching it and see you on next work.